In this video, we're going to simplify expressions containing integer exponents, and we're going to use the rules of working with integer exponents. So here are the rules listed here, just as a reminder. This is the multiplication rule. When we multiply two integer expressions with the same base, we simply add the exponents. Okay, like x squared times x cubed is equal to x to the fifth. Or when we divide something, we subtract exponents. Okay, like x to the 10th divided by x to the 7th is x cubed. Or here we have an integer expression raised to another, an exponential expression raised to another exponent. For example, x to the 10th cubed is equal to x to the 30th. We multiply the exponents. This one simply says that anything to the exponent 0 is 1, like 5 to the 0 is equal to 1. This is true as long as a is not equal to 0. Okay, here this says that this defines negative exponents. A to the minus n is equal to 1 over a squared. For example, 2 to the minus 3 is equal to 1 over 2 cubed, or 1/8. And here we have a fraction raised to a negative exponent. We take the reciprocal and we make the exponent positive. We could write it like this. We could add one more step. A over b to the minus n is equal to b over a to the n. And then when we open up parentheses, we get b to the n over a to the n. All right, let's look at this first expression. So here we're going to use the rule for multiplying integer expressions with integer exponents. All right, we're going to multiply 7 times 3. And then we'll multiply the x's, the expressions with the same base, x cubed, x to the 5th, adding those exponents, 3 plus 5, so we have x to the 8. And then y squared, y to the 4th, again, add the exponents, and we have y to the 6th. In the second example, we're going to use the rule for subtracting exponents. So here we have x7 in the numerator, x to the 4th in the denominator. Subtract those exponents, 7 minus 4, and we get x cubed in the numerator. Now here, we're going to reduce in the usual way, just dividing top and bottom by 5. And so we have a 2 in the denominator. Okay, in number 3, again, we're going to use the rule for dividing expressions with exponents. Okay, so first let's simplify the 7 over 21. Let's divide top and bottom by 7. All right, so we have a 3 in the denominator. All right, now let's look at the expressions containing x to the 20th divided by x to the 7th. Just subtract those exponents, 20 minus 7, and we have 13, x to the 13 in the numerator. Now over here, notice we have y cubed over y to the 5th, and notice now the numerator, the exponent in the numerator, is smaller than the exponent in the denominator. So we could subtract and get y to the minus 2 in the numerator, or we could think of this as dividing top and bottom by y cubed. So if we do that, on top we have 1, and divide y to the 5th divided by y cubed, and we have y squared. So we have y squared in the denominator. All right, so it's either y squared in the denominator or y to the minus 2 in the numerator. In number 4, we're going to cube the expression in parentheses, cubing everything. First, let's do 3 cubed. 3 cubed is 27. 3 times 3 is 9, times 3 is 27. Then we're doing x cubed cubed, and now we're going to use the rule where we multiply exponents. All right, so we're using this rule, a to the n to the m, a to the nm, multiplying the exponents when we have a power to a power. Okay, so we have x to the 3 times 3, that's x to the 9, and then y squared cubed multiplies those exponents 2 times 3, so we have y to the 6. All right, and number 5, 7 to the 0, we know that's equal to 1. All right, and number 6, we could simply subtract exponents, but what I like to do is rather than subtracting -5, subtract -3. I like to switch this around so we have first an expression with positive exponents. Now the 2 and the -3, they stay where they are. Neither one has a negative exponent. -3 is a negative number. It doesn't it doesn't have a negative exponent, okay, as opposed to, let's say, 3 to the -1. So this just stays where it is. Now this x to the -5, we can write in the denominator as x to the 5, change the exponent to a positive 5, and x to the -3 in the denominator, also just switch sides, bring it to the numerator, and we have x cubed in the numerator. Okay, now we're ready to reduce this by dividing top and bottom by x cubed. So we'd have a 1 here, and x fifth divided by x cubed, that's x squared. All right, so we're left with a 2 in the numerator and -3x squared in the denominator. Okay, in number 7, we could just use this rule here, multiplying the exponents, and we get -7 times -4 is 28. So this is x to the 28. In number 8, we have this exponential expression in parentheses with a negative exponent outside the parentheses. And here we have to be very careful because when we raise 2 to this negative exponent of -3, all right, we get 2 to the -3, which is 1/8. And a lot of people make mistakes at that point. Let me do this 2 ways. All right. First, I will raise everything in parentheses to the -3. So we have 2 to the -3, and here x to the -5 to the -3. We will multiply these exponents and get x to the +15. So that's equal to 1/8 times, that's 2 to the -3 is 1/8 times x to the 15. Or I guess most people would write this as x to the 15 over 8. All right, so that's one way of doing this. But I find a lot of people make mistakes at this point, forgetting to raise 2 to the -3 or not doing that properly. So here's another way that I suggest, and this is the way I will continue doing these examples. If we have an exponential expression with in parentheses and the negative exponent outside the parentheses, I'll first convert this to the reciprocal and change the negative exponent to a positive, to +3. So I'll only open parentheses when I have a positive exponent outside the parentheses, just to avoid any possible errors. So now we do 2 cubed is 8, and x to the -5 cubed multiply, and we have x to the -15. And now we have one more step. We're going to take this x to the -15 and bring it up into the numerator as x to the +15. So of course we end up with the same answer. All right. And like I said, I'll be doing it this way, the second way. Okay, number 9. Again, we have in the numerator, we have this exponential expression and the negative exponent on the outside. So what I'm going to do is bring this entire numerator into the denominator and change the -3 to a +3. So that leaves me with a 1 in the numerator. And in the denominator, we have -2 x to the -4 to the +3. And then we have that 2x to the 5th. Notice that when we bring this expression to the denominator, this exponent stays as -4. We basically just copy whatever's inside parentheses, we copy it exactly as is into the denominator. The only thing that changes is this exponent. All right, so now we're ready to open up parentheses. Here we have -2 cubed, that's -8. X to the -4 cubed, that's x to the -12. Multiply those exponents. Here we have 2 to the 5th, that's 32. And x to the 5th over 1. Okay, so just in the last step, I'll continue it over here. We're going to multiply -8 times 32, that's -256. And then we could multiply x to the -12 times x to the 5th, just add those exponents, -12 plus 5, that's x to the -7. And as a final step, we'll just take that x to the -7 and bring it up to the numerator as x to the +7. And leave the -256. That stays in the denominator. Okay, it's a negative number. It does not have a negative exponent, so just leave it where it is. In number 10, we have a fraction to a negative exponent. So we're going to use that reciprocal rule. All right, here's the reciprocal rule. If we have a over b to the -n, we take the reciprocal, b over a, and just change the negative n to a positive n. Okay, so let's use that in this case. So we're going to take the reciprocal and we'll change the -3 to a +3. -3 cubed, that's -3 times -3 times -3, that's -27. And x to the 7th cubed, multiply those exponents, and we get x to the 21. Divided by 5 cubed is 125. In number 11, we have an exponential expression with a negative exponent. So the first thing we'll do is bring this whole expression in the denominator underneath the second expression. So we'll change this to 3x to the 5th y to the 4th squared. Okay, I'm just copying over the second expression. That'll stay in the numerator. And in the denominator, we'll have -3x to the -2 y squared, and I change this to a +2. So now we're ready to open parentheses, top and bottom. Okay, 3 squared, that's 9. X to the 5th squared, multiply those exponents, 5 times 2, so we have x to the 10. Y to the 4th squared, multiply 4 times 2, we have y to the 8. And now in the denominator, -3 squared. Now the entire -3 is squared. That's -3 times -3 is +9. Okay, here x to the -2 squared, multiply the exponents, we have x to the -4. And here we have y squared squared, that's y to the 2 times 2, y to the 4th. And now let's do a little simplifying. Okay, we can reduce that, cross off the 9s. Y to the 8th, y to the 4th. Well, let's just... We'll subtract 8 minus 4, we get y to the 4th. Okay, so we did that. Now, these x's, we're going to take x to the -4 and bring it to the numerator. Okay, we'll just be left with 1 in the denominator. All right, so we'll have x to the 4th in the numerator, also x to the 10th. Multiply these by adding exponents, and our final answer will be x to the 14th y to the 4th. In number 12, we have a fraction to a negative exponent, so we're using the reciprocal rule. Okay, take the reciprocal of the inside, that's y to the 5th on top, minus 2x to the minus 3 in the denominator. Change the minus 2 to a positive 2, and now we're ready to open parentheses. Y to the 5th squared, multiply those exponents, and we have y to the 10th. Minus 2 squared, again the entire minus 2 is being squared, so that would be 4. And x to the minus 3 squared, that's x to the minus 6. And now we're just going to take this and bring it up to the numerator and change the minus 6 to a positive. Alright, x to the 6 in the numerator, and leave that 4 in the denominator. In number 13, we want to simplify this expression, and we'd like to use our division rule, but we need the same base. Here we have base 9 and base 3. So what we're going to do is we're able to switch over to the same base by changing 9 to 3 squared. So let's write 9 as 3 squared. So we have 3 squared to the exponent 5,000. And in the denominator, we have 3 to the 9,999. Open parentheses by multiplying these exponents, and here in the numerator we get 3 to the 10,000. In the denominator, 3 to the 9,999. So now we can just subtract our exponents. 10,000 minus 999 is 1. So we get 3 to the 1, or 3.